All right, let's go over your work from part 1. If you have an answer that's different from mine, you want to pause your video, look really closely at my truth table, compare it to your truth table, and find out where you made a mistake. Or where I made a mistake. Believe it or not, it happens. All right, number 1, we have a tautologous statement. That means that when we look underneath the main operator, the column under the main operator, we see nothing but true for truth values here. It doesn't matter whether or not the statement n is true, as it is on line 1, or the statement n is false, as it is on line 2. This entire statement is always true, no matter the truth value of n. Number 2, though, is contingent. Whether or not this entire statement is true depends on what the truth value is of g. When g is assumed to be true, as it is on line 1, then the entire statement is true. But on line 2, where g is assumed to be false, the entire statement is false. So this statement is contingent. Number 3 is self-contradictory. This is a statement that kind of eats itself up logically. When we look at the column underneath the main operator dot, we see nothing but truth values of false. It's impossible for this statement to ever be true. This truth table represents the entire set of possible conditions that could exist, the entire inventory of possible truth value combinations for S and R. And we see that there is no combination of truth values for S and R that would allow this statement to ever be true. It's self-contradictory. Number 4 is another contingent statement. Whether or not this statement is true or false depends on the truth values of the component statements, the component propositions E and F. And we can see here that sometimes this statement is true, and sometimes, like on line 3, it's false. So we have a contingent statement. And finally, for number 5, we have another self-contradictory statement. Again, one of these statements that kind of eats itself up logically. There's something wrong with the structure of this statement that prevents it from ever being true, no matter what the truth values of K and H are.